Last two questions for the practice test. So this is a very classic closed pipe question, resonance question. And it says, so we have a closed pipe here. Now, the reason I wanted to spend some time is because we're not doing the lab. So you have a tuning fork and you hold the tuning fork over this pipe, and then you move the pipe up and down, or just move it up. And what happens is when you're doing this lab, you hear no sound, and then all of a sudden you hear, and then it just appears, and then you hear another sound, and it's the frequency of the tuning fork. So you hear sound, and then as you're lifting the pipe, as the pipe is moving, in other words, the length of the pipe is changing. You hear no sound, and then a little sound, and then no sound, and that is the nodes and the antinodes, right? So if there's no sound, what's happening here? You've created a node at the opening of the pipe. If there is sound, then you've created an antinode. Or the first one I did was quarter wavelength, or 3/4 of a wavelength, or 5/4 of a wavelength, and so on. So you keep moving the pipe up, and then it keeps going from node to antinode. And wherever you hear the loudest sounds, that's where the antinodes are. And then you measure the length of the pipe, and you can determine the frequency of the tuning fork from that. So this question says the shortest length of tube for which a tuning fork A produces resonance is, so in other words, produces, when it says produces resonance, it means produces an antinode. Which equals sound. The speed of sound is 322, then the frequency of the tuning fork. So in simple terms, this is just a frequency equals velocity over wavelength. We know the velocity. We just need the wavelength. And what the question says is at 15.6 centimeters, that's the shortest length. So let's go back up to here. If that's the shortest length, the question is how much of a wavelength is that? And we should know from for closed pipes, the shortest wavelength that will produce an antinode at the opening is 1/4 of a wavelength. And if 1/4 of a wavelength represents 15.6 centimeters, then a full wavelength is that times 4. Right? So that equals 62.4 centimeters. That equals a full wavelength. So 1/4 of a wavelength equals 15.6. Multiply it by 4. Now you get a full wavelength. Now you can plug that into the formula. After you change it to meters and get the answer, which turns out to be 516 hertz. All right, and the last question of the practice test is, looks like it's a Doppler effect question. A jet with a frequency of 685, it's moving toward you at that speed. The speed of sound in air is 321. The wavelength, that's a little wrinkle there. It asks for the wavelength of sound you detect. Good, I'm glad we're doing a question like this because something will come up at the end where you have to make a decision. So Doppler effect toward you. So it's a minus. Plug in the numbers. And you end up getting 1,182 hertz. which seems very reasonable, right? It's moving towards you at a very high speed, 135 meters per second. So it's moving to, so you're going to hear a much higher frequency than the actual frequency. But the question asks for wavelength. They don't want to know the frequency, they want to know the wavelength. So we just use the universal wave equation. We've got the 1182. The only question you have to ask yourself is, what am I using for the velocity? The velocity of the thing moving, or the velocity of the sound in air? And if we're wanting, think about this before you jump to the wrong answer. It says if the speed of sound in air is 300, the wavelength of the sound that you detect, the wavelength of the sound that you detect. So we definitely have to use the 321. Because that's the wavelength, because that's the speed of sound in air is that one, but we want the sound that you detect. So the speed of the sound in air that you detect, and it's going to turn out to be 0.72 times 10 to the negative 1. Nope, 2.72 times 10 to the negative 1. So yeah, 0.72 meters is the answer to that question, and that's the end of the practice test.